When storm chasers talk about good moisture, what do they actually mean? It turns out that one number, the dew point, can tell you almost everything you need to know about how primed the atmosphere is for severe weather. In this episode, we break down why moisture is the first ingredient forecasters look for when evaluating a severe weather setup. If the atmosphere isn't moist enough, storms struggle to form at all. But when moisture is abundant, the stage is set for explosive convection. Let's start with the foundation of every storm environment. I'm Gabriel Harber, host of the Storm Chaser Coaching Podcast, and I'm here with lead coach Trey Greenwood. Trey, how you doing here today?
I'm doing well, thanks.
Before we get started with the first question, I want to remind folks we do have a cheat sheet. That's the notes for this podcast that we derive the outline, the questions from. There's a link in the description below to a form you can fill out. It gets you direct access to the notes for this podcast and every podcast episode. So if you want to follow along that way or just have those notes for future reference, highly recommend checking that link out. Okay, Trey, question number one here. Why is moisture considered one of the most important ingredients for severe storms?
Moisture is like storm fuel. If you don't have the fuel to fuel those storms, you're not going to get robust storms. Now, you can have storms in environments with more meager moisture, but they're probably not going to be ones that you'd want to chase all that much. You want to see good amounts of moisture in most cases, and we'll talk about some of the differences when you have terrain involved later. But moisture generally is one of the most important variables because these storms feed off of that moisture, and they just need that moisture to survive in most cases.
So obviously, as we mentioned in the intro, dew point is the way that we actually quantify how much moisture is available. What exactly is dew point? Because I think a lot of people have heard humidity or relative humidity throughout their lives on, for instance, the Weather Channel or maybe their local weather forecast. But meteorologists, storm chasers, dew point is the much more common term, the much more helpful term. So if you could just share with people what is dew point and why is it the thing we use instead of humidity?
Yeah, so dew point is the temperature to which air must cool in order to form dew, as the name suggests. So it's the temperature to which air must cool in order for the air to condense. It's the point at which water vapor occurs. So if air cools down to the dew point, you're going to get condensation and water droplets and water vapor. The reason why we use it over relative humidity is because it's an absolute measure of moisture in the atmosphere. Relative humidity, hence its name relative, it's dependent on temperature. So it's going to change quite a bit if temperature changes. But if temperature changes and we're talking about dew point, the dew point generally is going to stay the same. So it's an absolute measure of the quantity of moisture in the atmosphere. It's a much more reliable indicator of moisture than relative humidity is.
And when you say condensation, that is roughly synonymous with clouds, right? If you don't have a dew point that can produce condensation, then you don't have clouds, i.e., you don't have storms.
Yeah, that's generally the case. And if anyone's experienced fog before, which I think most of us have, that's when your air at the surface cools down to the dew point. So you'll see a surface temperature of maybe 50 degrees with a dew point of around 50 degrees. That is the point at which you're getting condensation. Now, there's some science out there, and that you can get what's called supersaturation. So you can get relative humidities above 100%, which would technically mean the dew point is greater than the temperature. But in the vast majority of severe weather cases, for really any importance for severe weather forecasting, it's that dew point's never going to be greater than the actual air temperature. It's again the point at which the temperature to which air cools to in order to condense into essentially clouds.
Now, I'm going to take a stab here, and that's always dangerous because I am not the expert. But when you were talking about how relative humidity is associated with temperature, is that why, for instance, if we have a dew point and a temperature that are close, but it's say 25 degrees Fahrenheit outside, the relative humidity might actually be low?
So it really depends on, so what it's based on is the expansion and contraction of air when it's colder versus warmer. Warm air expands. So let's say we have a certain amount of moisture. Think of it as just a box that's filled with a certain amount of water. If you have that box and the temperature increases, that box of air is going to expand. You still have the same amount of water, but the box of air is going to expand because it's warmer. So your relative humidity is going to decrease drastically, even though we have the same amount of moisture in that box of air. Now, when it's colder, that box of air is going to contract. So you're going to have the same amount of water, but that space that box of air is taking up is much less because it's colder, it's contracting. So again, even though you have the exact same amount of moisture, the quantity of the moisture hasn't changed, but the relative humidity has gone up because the space with which that air is taking up is decreasing, it's contracting.
So the TLDR is I was 100% wrong in the complete opposite direction with the way that I was thinking about it.
Yeah, it just has to do with the basic tenets of meteorology that warm air tends to expand, cold air tends to contract, but you still have the same amount of moisture in that environment. So the relative humidity is going to fluctuate greatly. It's going to usually decrease when the air gets warmer, and it's going to increase when it gets colder.
By the way, I'm doing this as a service to all of our listeners. I'll ask the dumb questions. That way I can feel silly, and Trey can go ahead and set me straight. That way you don't have to. I do want to tell you folks about something really cool before we move on to the next question, which is our Discord community. If you guys are on Discord and you're looking for a place where storm chasers are always talking, we have a really cool place called the Forecasting and Chasing Forum, actually, which as storm chasing season picks up, there are discussions going on about each individual day, the long range forecasts, and everything in between. So check out the link in the description below if you'd like a place to talk more about severe weather, storm chasing, forecasting, all that jazz. Trey, next question. Which dew point ranges are typically associated with severe weather and tornado outbreaks? And I ask that question knowing that there is not an absolute range where this is X and that is Y, but just typically speaking, if we're eyeballing a forecast model or we're eyeballing some information on like the Weather Channel app or something like that, what kind of dew point ranges should actually have us sit up in our seat and take notice?
Like you said, there's no easy answer to this, and it varies based on things like terrain, time of year, etc. So this time of year, we're recording this in March, so it's early season. Temperatures generally are cooler, meaning you don't need as high of dew points to get robust severe weather. In the spring and late summer, say June, for example, you're going to need that higher moisture, generally, again, on the lower elevations. We'll talk about terrain here in just a second. But in the lower elevations, typically in the later season months, you're going to need a lot more moisture. Those dew points are going to need to be higher. Generally, as just a real general rule of thumb that I use, usually anything above 60 degrees Fahrenheit for dew points is typically considered okay. In a decent amount of severe weather setups, that might not be the case certain times of year, as we said, but in a good amount of severe weather setups in your typical springtime time frame, you're going to want to see those dew points up near 65 degrees, maybe 70 degrees for an optimal setup. But again, it varies quite drastically based on time of year, terrain, etc.
That leads right into the next question, which is why does the temperature dew point spread matter for storm development?
So that is going to deal with how outflow dominant a storm tends to be. So when the temperature dew point spread at the surface is higher, that's going to be the difference between the air temperature at the surface and the dew point at the surface. When that is higher, that tends to lead to higher cloud bases and an overall slightly drier environment in the low levels below that cloud base. So when you have downdrafts and precipitation that is falling out of a storm, it's going to evaporate in that slightly drier environment. The air then cools, it accelerates because that air is now more dense because it's cooled down. So it accelerates as it reaches the surface, and then as it hits the surface, you get strong outflow wind gusts. And of course, outflow dominant storms tend to be less favorable for tornadic activity because that cold outflow can undercut that low level mesocyclone that you need for the tornado to develop. So you want your temperature dew point spreads to be somewhat on the low side. A general rule of thumb is anything below 20 degrees Fahrenheit as a temperature dew point spread is considered a favorable temperature dew point spread for tornadic activity. Again, this varies on terrain. This rule is broken when terrain is involved. But for most cases on the lower elevations of the plains and in the southeast or Midwest, typically you want that temperature dew point spread to be on the lower side, generally below about 20 degrees Fahrenheit or so. That leads to a lesser likelihood of strong outflow production with storms that can hamper tornado production.
And the last question I will leave out all of our listeners with, Trey, is a specific scenario like you just mentioned, but one that I think a lot of people find very tricky, and that is upslope regimes. Why can severe storms sometimes occur with lower dew points in higher elevation areas like the Texas Caprock, or as you start to get closer to the Front Range in Colorado? Why is it that like a 50, 55, hell, sometimes even like a 45-degree dew point can actually get the job done?
Yeah, I've seen tornadoes happen in Colorado with dew points in the upper 30s. So higher terrain definitely makes a difference. And the reason is that air at higher elevations doesn't hold as much moisture by nature. You can have a dew point of, say, 50 degrees in Denver, and that's going to be more than enough. That's going to be akin to, say, a 60 plus dew point at a lower elevation place like Wichita or Oklahoma City. And so if you see moisture getting up into the upper 50s in Wyoming or Colorado or even the Texas Panhandle, the Caprock, that is akin to very significant moisture for those higher terrain regions because by nature that air at higher elevation can't hold as much moisture. When you're chasing the higher terrain areas like a Wyoming, Colorado, anywhere in the high plains there, New Mexico, a dew point in the 50s can be more than adequate even later in the season because you're on higher terrain and the rules that we talked about earlier go out the window. And dew point of, say, 57 degrees at Denver, that's a pretty high dew point for the higher terrain just because of the fact that the air at higher elevation can't hold as much moisture.
And now, folks, you will know what it means when a meteorologist on television is talking about how good moisture is in place, or you see somebody on Twitter talking about how there just wasn't enough moisture to get the job done. Remember to check out those links in the description below, and then watch another video.